In this pencast, we're going to be solving word problems using quadratic equations. This problem says, a pilot of a helicopter plans to release a bucket of water on a forest fire. The height y in feet of the water t seconds after its release is modeled by y equals negative 16t squared minus 2t plus 500. The horizontal distance x in feet between the water and its point of release is modeled by x equals 91t. At what horizontal distance should the pilot release the water in order to hit the target? Alright, so our goal in this problem is to find x. Alright, so x equals 91t. So x is a function of t. So the first step is going to be to find t. Alright, so we want to find the time it will take for the water to hit the ground. So we know that the height y in feet of the water t seconds after its release is modeled by y equals negative 16t squared minus 2t plus 500. So we want the height y to be 0 because we want the water to have hit the ground. And we want to solve for t when the water's hit the ground. So we get negative 16t squared minus 2t plus 500, and we set that equal to 0. So to solve this, let's use the quadratic equation. So we're going to have t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so let's plug in our coefficients here. We're going to get t equals negative 2 plus or minus the square root of negative 2 squared minus 4 times negative 16 times 500. Alright, all of that over 2 times negative 16. Alright, so let's start simplifying under the square root. So we're going to get t equals, so 2 plus or minus the square root of 4 plus 32,000 all over negative 32. That's the same as 2 plus or minus the square root of 32,004 all over negative 32. Alright, so if you put that in your calculator, you're going to end up getting 2 plus the square root of 32,004, which is 178.897 all over negative 32, or 2 minus 178.897 all over negative 32. So t is equal to negative 5.65 or 5.53 seconds. Alright, so we don't even need to worry about this negative 5.65 because there's no negative time. So that doesn't make sense in the context of the problem. So now we know that we have t, which is equal to 5.53 seconds, which means that it takes the water 5.53 seconds to hit the ground from when it's released. So now we can say x equals 91t, and we can plug in 5.53, so that's 91 times 5.53. Alright, so x is equal to 503.23 feet. Alright, and what that means is that the pilot needs to start releasing the water 503.23 feet away from his target in order to hit his target.